Okay, we're just going to do this example problem from the end of the notes yesterday, and then we'll launch further into today's activities. So we're supposed to be converting 5.712 grams into both milligrams and kilograms. Okay, so to do this, we'll need to use the conversion chart that I shared with you guys, which apparently my computer doesn't want me to have access to today. Here it is. Just not showing up. Now it is. So this is the conversion chart I was talking about. Oh, why does my computer hate me? There we go. Like this, and then we'll just have to zoom out a little bit. Okay. So this is the conversion chart that I was talking about. And you can see, so if we're putting the base unit grams in here, okay, where this blank line is, okay, then that means that there are 10 grams in a decagram, 100 grams in a hectogram, and 1,000 grams in a kilogram. And if we're going the opposite direction, that means there is 0.1, so a tenth of a gram in a decigram. Or if you want to say that a different way, you could say there are 10 decigrams to 1 gram. There's a hundredth of a gram in a centigram, so 100 centigrams to 1 gram. And then there's a thousandth of a gram in a milligram, or there are 1,000 milligrams for every gram. So we're going to use these, what we will call conversion factors, to help us convert between. So hopping back over to the example problem, okay, we're starting with 5.712 grams, and we want to end up with milligrams. Okay? So what that means is we need a conversion factor with grams on the bottom and milligrams on the top, okay? So that we can use this to cancel the grams and then convert to milligrams. We're essentially multiplying by this conversion factor. So there's a couple we could choose from. We could choose to say, like we did, that there's 0.001 grams for every 1 milligram. Or, in my opinion, a simpler way is to remind ourselves there are 1,000 milligrams for every 1 gram. And we got that back off of the chart that we looked at. Okay? So if we do it this way, then grams cancel, and we wind up just taking 5.712 times 1,000, which comes out to 5,712 milligrams, being our answer for that conversion there. Do we understand why milligrams needs to be on top and grams needs to be on the bottom? Yes. Yep. I don't have it written in there, but if it helps you visually to understand that that's over 1, you can absolutely put that in there. Okay. All right. So if we're going to do this to kilograms then, we're starting with the same amount. We still have 5.712 grams to start with. And you put it over a line if you'd like. Okay. So now we need a conversion factor that goes from grams to kilograms. So if you remember, we said there were 1,000 grams in every 1 kilogram. Okay. So again, grams is on the bottom because we want grams to cancel out. And then this time, instead of multiplying by 1,000, we wind up dividing by 1,000, which means we're just going to move that decimal place 3 spots and wind up with 0.00571 kilograms. You can do conversions like this with any conversion factor, even ones that are not metric based like this. So, for example, if I told you there was like a basketball player, and this basketball player had a 34-inch vertical jump, okay, and I asked you, what is that vertical jump in centimeters? Okay, well, you would need a conversion factor between inches and centimeters in order to accomplish this. Okay, I just happen to know this one off the top of my head. If you didn't know it, you would need to look it up. So you might look it up online, you might look it up on that chart. Now that chart only has metric prefixes, it doesn't have any inches on it, so it won't be helpful for you for this one, okay? But I just happen to know that for every 1 inch, there is 2.54 centimeters. So then inches cancel, we take 34 times 2.54, and it comes out to be like 86 something, I think. Okay? Centimeters. So you can use this to convert anytime you know the conversion factor. So if you're converting from hours to seconds, knowing there's 3,600 seconds in an hour, that's your conversion factor. You just have to find two things that are equal. 1 inch is equal to 2.54 centimeters, so we can use this conversion factor. It's really nice and handy that these are all powers of 10. So you know as you're going up, if you have 1 gram, okay, then it'll take 10 of them to make a decagram. It'll take 100 of them to make a hectogram. It'll take 1,000 of them to make a kilogram. It'll take, I believe that's 1,000,000 of them to make a megagram, okay? And then as you go down, it gets smaller. So it'll take only 1/10 of a gram to make a decigram. Or, like I said, you can flip that in your brain and realize that if we were going up still, like we were before, it takes 10 decigrams to make 1 gram. It takes 100 centigrams to make a gram. It takes 1,000 milligrams to make a gram. Okay? So this will be provided for you. You can use this anytime. Okay? I believe last year I even allowed them to use this on the test because I don't expect you to memorize all of the prefixes. Okay? But I do expect you to know how to use them. There is practice for this on your homework for today, which is page 46, questions 1 through 6 from your textbook. Okay? If you get stuck on that homework, come and see me. I am more than happy to help you with it.